Welcome to Pre-Calculus Section 4.1, 4.2. Now we're ready to do some graphs of rational functions. So in this example, we're going to practice finding this whole list of stuff. So the very first thing that we need to do is factor the top and the bottom of our function. So let's factor the top. So we've got 3 times negative 20 is negative 60. 1, 60, 2, 30. 320, 415, 512, 610. So we have to add to give positive 7 and multiply to give negative 60. So we need a negative somewhere. Now let's see where we're going to put it. So we're going to put it on the 5 here. Negative 5 plus 12 is 7. So I've got 3x squared plus 12x minus 5x minus 20, split down the middle, factor out a 3x, so that gives me x plus 4, bring down a minus, factor out a 5, x plus 4 also over here, so my factored form is x plus 4, 3x minus 5. So let's just put it over here. X plus 4, 3x minus 5. All right? Now we'll factor the bottom. So we've got 30, 130, 215, 310, 5, 6. So we have to multiply to give a positive 15, add to give a negative 13. So we're going to choose those two factors. Replace negative 13x with negative 3x minus 10x and then plus 15. So we're going to factor out an x, bring down the minus. We have the same factor here. So our factored form is 2x minus 3, x minus 5. So let's just go in order of the things we're asked to do here. First, x-intercepts. So in order to find the x-intercepts, we look at the factors in the numerator and find out the x values that cause these factors to go to 0. So we can see that the x-intercepts are going to be x is equal to negative 4 and x is equal to 5/3. So those are the points negative 4, 0 and 5/3, 0. Those will be in our graph. The next thing is the holes. So we want to check and see if any of these factors match up top to bottom. Can go diagonally as well. None of them match up either up, down, or diagonally, so there's no holes. Well, we forgot the y-intercepts. So the y-intercepts, so there'll be 1, are going to occur at the f of 0 location. So y-intercepts, so we're talking about plugging in 0 for x. So if I go ahead and do that, I'm going to say I've got 0 plus 4, 3 times 0 minus 5, let's put that, 2 times 0 minus 3, and 0 minus 5. So I've got 4 times 5 divided by minus 3 times minus 5. So let's cancel that out and that out. So I've got 4 over negative 1 times negative 3, which is 3. So my point for my y-intercept then is the point 0, 4/3. All right, so next thing we're going to do is our vertical asymptotes. To figure out our vertical asymptotes, we find out where the factors in the denominator go to 0. So I can see for this factor, x is equal to 3/2 is going to be a vertical asymptote. And for this factor, x is equal to 5 is going to be a vertical asymptote. So they have to be written as equations of vertical lines like we have them. X is equal to a number. All right, so next we'll do the horizontal asymptote. So to do that, we're going to go back here to the polynomial form, and we're going to examine the two highest order terms, one in the numerator, one in the denominator, and I could see that I've got the same degree in the top and the bottom. So that's the case where your horizontal asymptote is the ratio of the coefficients of your numerator over your denominator. Okay, so I wrote that. Now the last thing we're asked to do is write the domain of the function. So the domain is all real numbers, taking out our domain restrictions. So our domain restrictions occur at the vertical asymptotes. So x cannot be 3/2 and x cannot be 5. So we're going to list those two x values. Those are our domain restrictions where our vertical asymptotes occur. All right, so we finished this example. Let's move on to another one. So this example says, write an equation for a rational function with the vertical asymptotes at 5 and -5, x-intercepts at -6 and -2, and a y-intercept at 4. Okay, so we're going to end up with the function f of x with a numerator and a denominator. So in order to get your numerator, you want to look at the x-intercepts. So from the factors, from the zeros or the x-intercepts, we can build the factors. So for x is equal to -6, we have x plus 6. That's this one. For x is equal to -2, we have the factor x plus 2. All right, now let's do the denominator. So we're going to use the knowledge we have here about the vertical asymptotes, two of those, to build the denominator. So remember, the vertical asymptotes are the x values that cause the factors in the denominator to go to 0. So we're going to build the factors from these x values for the denominator. So we're going to say x minus 5 and x plus 5 are the factors that go with these x values here and here. Okay, so now we've got our function built. The only thing we don't know is whether or not it's going to have a non-1 leading coefficient. And that's what this is used for here. Okay, so take good notes on this problem because you're going to see problems like this in your homework set. So from the vertical asymptotes, we're saying that's how you get your denominator factors. From the x-intercepts, that's how you get your numerator factors. From your y-intercept, that's how you're going to get your coefficient. So when I say coefficient of f of x, what I really mean is that you could have some number out here, let's call that a dummy variable a, that causes your y-intercept to be in the place we want it. So that means if your y-intercept is 4, f of 0 is equal to 4. So when x is 0, y must be 4, and that'll pin down that value of a. So f of 0 is equal to a times. Now, we can make this fairly straightforward if we realize that this is 0 here, 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 and here. So what we have is a times 6 times 2 over -5 times +5. So that's a times 12 divided by -25. And we're told that that has to be 4. All right, so we can write it a little better. We can say -12 over 25a equals 4. So we want that -12 over 25 to disappear, basically. So I'm going to multiply this by the reciprocal. On both sides. What you do to the left, you do to the right when we're solving. All right, so that's going to cause cancellation over here, and we'll be left with A. So A is equal to, let's do some canceling before I multiply. 4 goes into 4 once, 4 goes into 12 3 times. So if I multiply this number out, I'm going to get negative 25 on the top and 3 on the bottom. And now there's one more step to do, and don't forget to do this. If I give you a problem like this on a quiz, it actually says write an equation. It didn't say find A, but we need A to write the equation. So our equation, f of x, is going to equal to negative 25 over thirds times x plus 6 times x plus 2 divided by x minus 5 times x plus 5. All right, so now we've written it as an equation, and if you want to, you can distribute out those factors and then multiply everything by negative 25 over 3, but this is also an acceptable form. So this is our equation here. Let's go on to another example. Okay, so here's another problem, similar problem. It says, write an equation for the rational function with vertical asymptotes at negative 2 and 3, x-intercepts at negative 3 and 5, and a horizontal asymptote, y is equal to 6. So once again, the vertical asymptotes are going to give us the factors in the denominator, and the x-intercepts are going to give us the factors in the numerator. So make sure you're taking notes on this example problem, because you'll see one like this in your problem set. So let's go ahead and write the factors for the numerator using the x-intercepts. So we're going to have x, f of x is equal to x opposite sign 3, x opposite sign 5, and then in the denominator, the vertical asymptotes are giving us the factors, so we'll have x opposite sign negative 2, x opposite sign 3. All right? And then we have one more piece of information which will help us to pin down what's going on out front, what factor we have out here. All right? Sometimes I call it the coefficient, sometimes I call it the factor. Technically, I think factor would be a word that would be more applicable because we have a coefficient on the top and a coefficient on the bottom for the leading term. Okay, so let's just call that a factor. All right, so if the horizontal asymptote is y is equal to 6, let's think about our rules for horizontal asymptotes. Now, as we can see, the top, if I distribute all this out, it's going to have a leading term of power 2. And then on the bottom, if I distribute all this out, it's going to have a leading term of power 2 as well. All right, so the rule that would apply for figuring out the horizontal asymptote of this function would be same over same. So we want the ratio of the coefficients of the leading terms. So we're told that that ratio is 6. So that must be 6 over 1 in order to give you the ratio that they're saying is 6. So if the horizontal asymptote is y is equal to 6, then A must be 6. So I'm just going to erase that A right there, and I'm going to put a 6 right here. Okay, so this is your function. This is your equation. So make a note, if you've got a horizontal asymptote, y is equal to constant, then you must have had the same power in the numerator and the denominator, the same highest power in the numerator and the denominator, to give you that y is equal to a constant horizontal asymptote. So 6 over 1. All right, so here's another example. Write an equation for a rational function with a vertical asymptote. Let's cross out that s. At x is equal to 4/3, an x-intercept at -5/2, and a whole at x is equal to -3. Okay, so let's set it up. So we know f of x is going to have a numerator and a denominator. Well, if it has a whole at x is equal to -3, then it means there's a matching factor, top and bottom, x opposite sign. So x plus 3. All right, so there's our whole. It has an x-intercept at x is equal to -5/2. All right, so remember, when you've got a fraction like that for an x-intercept, then you've got 2x plus 5. Now, if you forget which of those two numbers goes first, write out your x-intercept like this, and then set it equal to 0 by solving. So if I multiply by 2 on both sides, I'm going to get 2x is equal to -5, and then to get 0 on that side over on the right-hand side, I'm going to add 5. I'll get 2x plus 5 is equal to 0. All right, and that's going to give you your factor, 2x plus 5. And you can show, if you go back the other way, you should end up 2x is equal to -5, x is equal to -5/2. You'll end up back at your 0. So you can go through that exercise if you forget the relationship between a fractional x-intercept and then a factor that has a coefficient in front of the x. The last piece of information that we'll put in there is the vertical asymptote, and we can build the factor associated with the vertical asymptote in the same way. If x is equal to 4/3, then the associated factor is going to be 3x minus 4. And you could prove that to yourself by using the same steps that I showed you for the 2x plus 5. Okay, notice on this problem, we don't have any more information about anything that could give us a number out front here other than 1. We're not told anything about the horizontal asymptote. We're also not told anything about where this function crosses the y-axis. So we're going to have to say that this right here is an equation that fits all these given conditions. So basically your understanding that is that there's a 1 here, and we don't need to write it. All right, so this is your answer. Let's try another one. Now we're going to move into doing some graphing. So we're going to graph the function f of x is equal to x minus 2 over x plus 4. First, let's draw in the asymptotes. So our vertical asymptote we're going to get by finding our domain restrictions from the bottom. So x plus 4 equals 0 gives you a vertical asymptote of x is equal to -4. And then the horizontal asymptote we're going to get by looking at the ratio of the highest powers of x and figuring out which rule applies. So for the horizontal asymptote, we get a y equation. So you can see you've got the same rule. So that's the ratio of the coefficients 1 over 1. So that means my horizontal asymptote is y is equal to 1. So I drew in the vertical line for x is equal to -4 and the horizontal line for y is equal to 1. And as we mentioned, our asymptotes are drawn as dotted lines. Let me just add that it's a good idea to use a colored pencil or a highlighter to draw your asymptotes so you can see clearly where your graph lies and it's not hard to read your graph. All right, now let's get some dots so we can find out where this graph lies. First thing, your x-intercept. So your x-intercept occur when you have zeros on the top. So when x is equal to 2, you're going to have a 0 on the top. So that's your x-intercept, 2, 0. Okay, so I can put a dot at 2, 0. I know my graph is going to cross my axis, my x-axis, at the point 2, 0. Next, let's get our y-intercept. Your y-intercept is f of 0. So you're going to put 0 in wherever you've got an x. So you've got 0 minus 2 on the top, and you've got 0 plus 4 on the bottom. That's negative 1/2. So you've got the point x is 0, y is negative 1/2. All right. So now we can get a few more points in here. Now the most important thing to realize is that these are functions when you're graphing these. So what that tells me is that if I've got dots down here, my graph is going to lie in this sector, this quadrant, separated by these dotted lines. So you've got this quadrant over here, this quadrant over here, this quadrant here, and then of course this one here. So if my graph lies down in this quadrant and it's approaching the horizontal asymptote and also the vertical asymptote, you could be sure that it's not also up here, because then it wouldn't pass the vertical line test. So we can get a few dots to prove that to ourselves. After a while, you get the hang of where these things are just by having only a few dots. So I know it's going to go here. Now, and I also know it's going to go up here like this, and it's going to approach the horizontal asymptote. So let's get another point down in this area down here. So let's see, let's plug in, maybe I'm just going to pick x is equal to negative 2. So if x is equal to negative 2, and you know that was somewhat of an arbitrary selection, I just want to see what the shape of my graph is as it starts to approach the horizontal asymptote, the vertical asymptote here, down in this region here. So when x is equal to negative 2, in the numerator I've got negative 2 minus 2. In the denominator I've got negative 2 plus 4. So that's negative 4 over 2. So that's negative 2. So that's the point. That's the point, negative 2, negative 2. All right, so it's going down here, and I can get as many points as I want, but you should have enough points plotted so that you can, so I've got 3 points here. That's a good amount. You could have put another one up in this region here to get this behavior pinned down a little bit better, but it's going to have this basic shape here. So this is fairly accurate. All right, now let's see what it does on the left side of this vertical asymptote. It's going to split. So it's going to split here. So we want to know, is it going to go like this in that piece, in that quadrant, or is it going to go like this in this quadrant? So let's pick a couple points. So this is negative 4, so maybe negative 6. Let's try that one and see where that goes. So if I plug in negative 6, I've got negative 6 minus 2, and I've got negative 6 plus 4. So that's negative 8 divided by negative 2. Let's see, is that right? So that's 4. So I've got the point negative 6, 4. So we can put that in here. So negative 6, 1, 2, 3, 4. So it's going to be up in that quadrant there. So if it's up there, here, then you're sure that it isn't down here, because it has to pass the vertical line test. And it has to approach the horizontal asymptote as x approaches negative infinity. And it has to approach and split here at the vertical asymptote. So we can get one more point in there. We can put in negative 8, for instance. So we'd get negative 8 minus 2 and negative 8 plus 4. That's negative 10 over negative 4. So that's, let's see, that would be 5 halves, which is 2.5. So let's say negative 8, 2.5. All right, so let's draw it in. Okay, so I've graphed it. Let's try another one. All right, here's another function. So we've got x minus 2 divided by x plus 4 times x plus 4. So that squared repeat factor in the bottom will cause some little bit of interesting behavior. So let's do the vertical asymptote first. So negative 4 will cause this factor and this factor to go to 0, but you only need to write it once. So my vertical asymptote is going to occur at the value negative 4, x is equal to negative 4. Now the horizontal asymptote is a y equation. So we're going to look at the powers in the numerator and the denominator. So I can see the highest power is 1 in the numerator. And then if you look at the denominator, if you can imagine these two distributed out, you can see that the leading term is going to be x squared. And you can go ahead and distribute that out if you need to. But this will help me figure out which case I have. So I have the case where the power of the numerator is less than the power of the denominator, which means my horizontal asymptote is y is equal to 0. So I'm going to go ahead and draw those in first. So it really helps to be using a different color when you've got to draw an asymptote over the axis, which is usually thicker. All right, now let's find the x-intercept. I have one factor in the numerator, which is going to lead me to an x-intercept of 2, 0. All right, let's put that point on there. So it's right on the horizontal asymptote. So behavior around horizontal asymptotes when you're not at the ends can cross over the horizontal asymptote. It's just when you get out to the very ends. Remember I mentioned earlier on that horizontal asymptotes describe the end behavior of rational functions. It is possible in the interior part here that you can touch it or cross it depending on what you've got as far as functions. But once you get way out here and way out to the other side, it's not going to be touching. It's going to be approaching the horizontal asymptote. All right, so there's one point. Now, so it's pretty unclear as to what's going on here still. So let's get the y-intercept. The more dots you have, the better off you are with your graph. The y-intercept is f of 0. So if I substitute 0 in to my function, I'm going to get negative 2 on the top and 4 squared, which is 16 on the bottom. That's negative 1/8. So I can plot the point 0, negative 1/8 on the y-axis. All right, so it's slightly clearer what's going on. But still, I don't have enough information to know exactly what's going on here and over here. We think it's going to settle down on the horizontal asymptote, but what's going on over here? And we don't know what's going on over here at all yet. So let's get some points here. Let's make a table. All right, so first I'm going to try a point. Let's try negative 3 and see where the graph lies close to the vertical asymptote. So I'm selecting points that are going to help me decide where to draw my graph. So I've got negative 3. So if I plug it in, I've got negative 3 minus 2 in the numerator. And I've got negative 3 plus 4. That's 1. 1 squared is 1. So I've got the point. Let's write my ordered pair. So this is negative 5. So I've got the point negative 3, negative 5. And let's just get one more point to the right of the x-intercept so I can see how long it takes to settle down onto that horizontal asymptote. So let's take the point 3, positive 3. That'll be to the right of the x-intercept. And I'll get 3 minus 2 in the numerator. 3 plus 4 is 7. 7 squared is 49. So this is a very small number. So it's settling down on the horizontal asymptote pretty quickly. So I can draw this in here. It's a positive number though, so it's up here really close. And then it approaches, well, it's hard to get that small number drawn in there accurately. But it does cross over the top of the horizontal asymptote into the positive region. All right, so there's that piece of the graph. Now let's go to the left of the vertical asymptote. So we could say this x value is negative 5 and see what happens there. So I've got negative 5 minus 2 is negative 7. Negative 5 plus 4 is negative 1, which square that and you get positive 1. So this is negative 7. So I've got a dot at negative 5, negative 7. I'm going to put one more, let's put one more dot in here. Let's try negative 7 just so we can get the shape in there pretty good. So that's negative 7 minus 2, that's negative 9. And then negative 7 plus 4 is negative 3 squared would be 9, so that's negative 1. So I've got the point negative 7, negative 1. Okay, so that should be enough information to get the graph in the right place. So it's going to swoop down like vertical asymptotes do. They approach the vertical asymptote, and then I'm going to approach the horizontal asymptote. And if you wanted to get a couple more points along here, you could, but that's enough to get a pretty good idea of how this thing is going. So the kind of weird behavior that you see because of that squared factor in the numerator is that it's approaching from under on this side, under the horizontal asymptote. It's approaching from over the horizontal asymptote on that side. Okay, so here's another example. So I've got x minus 2 times x minus 2. And then I've got x plus 4 times x plus 4. So let's get the vertical asymptote first. So the vertical asymptote is going to occur where the denominator factors go to 0. So I've got negative 4. So my vertical asymptote is x is equal to negative 4. All right, let's do my horizontal asymptote now. So you can see that the highest degree of the numerator is x squared, and the highest degree of the denominator is x squared. So this is the case where you're same. So you take the ratio of the leading coefficients. So it's going to be 1. So I've got a horizontal asymptote of y is equal to 1. So now I got my x-intercepts. So I got an x-intercept of 2. And it looks like it has a multiplicity of 2. So x is equal to 2, 0 is a point. But you can see that it has a multiplicity of 2. So we're going to expect a bounce at that 0. Okay, or a touch. All right, and then let's find our y-intercept. F of 0. So I substitute 0 in here. I'm going to get negative 2 squared, which is 4, over 4 squared, which is 16, 1/4. So I've got the point 0, 1/4. So since we have a bounce here occurring at the x-intercept, we're going to expect that the graph is not going to go underneath the x-axis. All right, but let's get a few more points in here to see what's going on. All right, so let's test a point over here. So this is 2. Let's see what's going on at 3. So when x is 3, I've got 3 minus 2, that's 1. 1 squared is 1. 3 plus 4 is 7. 7 squared is 49. So that's a very small number, but it's positive. So that's the point 3 comma 1/49th, which is some small positive number. So let's put a dot there. So let's just check and see whether this this graph stays underneath the horizontal asymptote for a larger value. So what I mean is, like, let's say, for instance, if we plugged in 10 into our function, are we still going to be underneath this horizontal asymptote here, but approaching it very closely? So let's just check it out. So I'm going to put 10 in there. So I've got 10 minus 2, that's 8. 8 squared is 64. And then I've got 10 plus 4 is 14. 14 squared, well, I think it's 196 or something like that. All right, so it's still a positive number, but it's definitely less than 1. So it's underneath. So 10, let's see, 6, 12, 18, I don't know. I'm just going to call it 0.3 roughly, just to get an idea. So let me put that dot on there. Okay, so we can say that it's going to bounce here, and then it's going to approach the horizontal axis. All right, so let's test a point between the vertical asymptote and this axis line here. So let's test a point -2. So -2 minus 2 is -4. -4 squared is 16. Then I've got -2 plus 4, that's 2. 2 squared is 4. So that's 4. So I've got the point -2, 4. So that gives me a pretty good idea that I'm going to start approaching higher and higher and head for my asymptote up here. All right, so now let's do to the left of the vertical asymptote. So let's take a point to the left. Let's try -5 and get a dot. -5 minus 2 is -7. Square that and you get 49. -5 plus 4 is -1. Squared is 1. So I've got the point -5, 49. So it's like really close, way up there. So I can't even get it on there. So it's clearly doing that. All right. Now, if we go, let's just get one more dot so we can see if it ever goes down below the horizontal asymptote. Let's try -6. So I've got -6 minus 2, that's -8 squared is 64. And then I've got -6 plus 4, that's -2 squared, which is 4. So that's 16. So I've got the point -6, 16. So maybe it's a little further away at that point. All right, so you can put more dots in there to get it as accurate as you want, but it's going to be up in that region there. All right. When I give you a graphing problem like this, I'll specify how many dots I want you to put in your XY table. So once again, do these by hand so you learn how to do it as opposed to using Desmos or something like that, right? Okay, this is the last example I'm going to do. I was going to do two more, but I think you're probably should be getting the hang of it by now. Now let's look at this one here. This one is not factored yet, so I'm going to factor this. And to save some time, the factors are these. All right, so what you can see here is that these two factors are going to cancel out, so that means you have a hole. So the hole is going to occur at x is equal to 2. All right, so we're going to have an empty circle. Remember I told you about the empty circles. So I'm going to show you how to plot one of these kind that have a hole. So let's get the coordinate pair for where the hole is. So remember, those factors are now canceled out. So to figure out where what the y value is, so we're going to substitute in 2. So basically, we're going to find f of 2. So that's 2 minus 3 on the top, 2 plus 4 on the bottom, negative 1 over 6. Okay, so I've got the point where I'm going to have a hole of 2 negative 1/6. So it's a small negative number. All right, so there's that. Now let's find the vertical asymptote. All right, so we won't have a vertical asymptote at x minus 2 factor because we canceled that out. It's a hole. So we will have one associated with getting a 0 for this factor. So that's negative 4. So we'll have a vertical asymptote of x is equal to negative 4. And let's do the horizontal asymptote for y equals. So you can see that your leading terms, since we're already distributed out, it's pretty clear to see that this is your same. So it's the ratio of the coefficients of your highest power terms. So this would be y is equal to 1. So let's graph those. All right, now we need some dots. So let's find the x-intercept associated with the x minus 3 in the numerator. So that's going to be the point 3, 0. And the y-intercept is f of 0, which is going to be 0 minus 3 divided by 0 plus 4. So that's the point 0, negative 3/4. So this one's going to have pretty straightforward behavior because it has a first order factor on the top and a first order factor on the bottom. There's none of that squaring stuff going on. So this looks like this piece is going to be down here. All right, we'll put the empty circle on last. And this is going to approach down here, and you could get some more dots in there to get it more accurate if you'd like. All right, so let's make a T-chart, get a couple dots to the left of the vertical asymptote. So let's try the point negative 5 for x. Substituting it in there, I'm going to get negative 5 minus 3. Negative 5 plus 4, that's negative 1. So I've got the point, so that's 8. I've got the point xy, negative 5, 8. So the behavior on this one is pretty straightforward. So the hunch here is that it's going to swoop down and it's going to approach the horizontal axis like that. But let's get one more point for 5, 6, 7, 8. For instance, maybe in this location here, where x is equal to negative 8. One more point. So that would be negative 8 minus 3, that's negative 11. Negative 8 plus 4 is negative 4. So that's 11/4. So I've got the point negative 8, 11/4. Well, 12/4 is 3. So this is approximately negative 8, 3, roughly. Let's see where that would go. So negative 8, 3, 1, 2, 3, so up here. Okay, so we can sketch it in now like this. it's going to head for the asymptote here and here. Okay, so now let's put our hole in there. So our hole is occurring at the point 2, -1/6. All right, so the hole, I'll put it in red, is right here. All right, so if I try to erase that line in the hole, I'll mess up my whole graph, but it technically, there's no line inside that hole at that point there. Okay, so this is your whole empty circle right there associated with these two factors here that canceled out. Okay, so that's all the examples I have for you. As usual, let me know if you have any questions about the problem set. So you should be ready to go, and I hope you took good notes.